Hello, my name is Mr. Turkal. As most of the development team members, I'm also a part of our delivery pipelines. And as a team, what we try to do is build and deploy the best product to our customers or the end users. So what we do is we prepare the functionalities or the features that the users need and push this application or the running code into production environments, to the environments where the users will interact with the application that we develop. So this is just a continuous set of activities, and everyone is somehow involved in this process. Some people are writing the code, which is a piece of code, which is a part of the application, and adding some unit tests to verify and validate these functionalities. Some other people are writing tests, end-to-end tests in the system level, and some people are trying to maintain the infrastructure. So somehow everyone is contributing to this whole process. But of course, this whole pipeline should be automated, right? It should be executed in an automated manner. If we try to do all these kind of activities manually, it would not be feasible. Think about large organizations or the big projects. Almost every second, a job or a workflow in the pipeline is triggered. So if they are not reliable or robust, it means most of them will fail, start failing, and even block the other jobs or the workflows. So our delivery pipeline will not be smooth, and we will not be delivering our features or maybe even the bug fixes, hot fixes as fast as possible. We would be blocked by these failures or the reliability issues, and we will not be delivering the high quality product to our customers. So in this session, I want to a little bit talk about the importance of reliability, and of course, I want to go over some tips to improve the reliability or the robustness of our delivery and the development pipelines. So I want to start with an early memory of mine, which was one of the enlightenment moments for me, where I understood sometimes the delivery or the shipment might not be as easy or as simple as I thought. If you know what this is on the screen, this is just a floppy disk. This means you are as old as I am. And when I was a kid, of course, I had some favorite games and some songs, but of course, I didn't have all of them in my personal computer. Some of them I saw in the internet cafe I was going, or I saw in my friend's computer. So I wanted to copy some of them to be able to play in my house, in my own personal computer. So what I did is I just dragged the games that I was playing into my floppy disk. By the way, it has a 1.4 44 megabytes capacity, but it was okay. We are not talking about large games, right? Not advanced screen resolution games as nowadays. It was just a basic car race, so it was okay. It could fit into this capacity, 1.4 megabytes capacity, but somehow it didn't work. I dragged all the icons into floppy disk, and when I was back home, I could still see them. It was there, but when I click, it didn't run because the issue was I did not copy the executable file, but just the icon, which was just a shortcut to the executable file. So this is a very childish memory of mine, but it was one of the moments that I really realized sometimes I need a more proper process to be able to deliver some application from one place to another environment where I will interact with the running code. So again, this is the old times when we had some desktop applications, which was basically even one executable file. Nowadays, we are talking about the products that we are developing or the products that we are testing are much more complicated, right? It is not maybe only one file. There are several different files compiled and bring together, and there are several dependencies. They should all be deployed into one platform, and everything should run all together smoothly, and the users should have a good user experience to be able to use this product that we are delivering to them. So of course, all these build and deployment, development activities again should be done in an automated pipeline. Everything is done by means of lots of different tools. Whatever we do, like we code our product in several development environments. We use different programming languages, and then what we do is we run some static code analysis, and then we initiate some environments, right? Execution environments, probably some containers in which we will put our application code and even some dependencies, and then we will compile, we will build, and we will prepare our packages, and then we will push them, upload them to some platforms where other people can either download or directly access from their remote platforms. Again, for all these parts of the whole chain, we may use some different tools. And of course, if some of this part or ring of the whole chain is not reliable, which means either it is failing where it was supposed to pass, which means it's a reliability issue, or even if it is not failing where it should, which means maybe we have an issue, we have a defect, we have a bug, but our pipeline is not capable of finding this issue. These are the reliability issues. On the one hand, the false alarms. On the other hand, the silent horror cases. Like there are some bugs, but my pipeline did not fail, so did not stop. So I was not aware of the issue. It is a silent horror case. So I just let the code go in production environment so that escaped bug will be in the production environments, right? People will see some issues, some maybe broken functionalities, or maybe some usability issues, some accessibility issues, whatever. Depending on the type of the bug, there will be some issues in the production environment. So this is some reliability issues. So in these kind of issues, the whole automation paradise might turn into an automation hell, because we are talking about a paradise, right? There are several different automated processes. We just push a button, like we prepare all the code in our environment, then add all files, commit, and push. Then this is called as push on green. Then everything runs automatically, and at the end of the pipeline, we can already see the code that we prepared in our production environment. Of course, there's a merging process and some other processes, but I mean, everything normally, if the code is ready, everything might execute automatically, and we can see the code that we prepared already in the production environments. But again, if the pipeline is not as smooth as we expected, then of course the nightmare starts. The pipeline will start failing unexpectedly when there is no failure, when there is no issue or bug. All the features are working as expected or as designed. If this pipeline is somehow failing due to some reasons, it might be some test flakiness, or it might be some dependency issues. If it is failing, then it's called the false alarm. And of course, it is not only the failures, but also the passing pipeline where there is an issue. This is also a reliability issue. The other side of the medallion, right? If it should fail, if it is passing, then again, we are talking about the reliability of the pipelines. So what can we do? Let's discuss lots of different insights. First of all, starting with the tooling. As we previously discussed, there are lots of different tools that we can use in all stages of the pipeline, right? Whatever we are doing, for example, if we are doing the testing, there are lots of different options that I can choose. For example, is it Playwright or Cypress, Selenium, Nightwatch? Which one is the best tool for me? Of course, the answer is not clear. It may vary from project to project. And what I can do is, first of all, analyze the requirements and the dynamics of the project, and then choose a tool which would work the best in my case. Like, for example, on which browsers I should execute my test cases in terms of cross-browser testing, or what kind of interactions I'll try to automate. Is it just clicking the buttons or passing some user parameters, or I will be dealing with some more tricky interactions, like dragging the mouse or opening a new tab, new window, or dealing with pop-up windows or drop-down menus. These are a little bit more challenging interactions to automate compared to other classical ones. So first of all, I can do this analysis, and after doing this benchmarking, I can choose the tool that I will use in my project. But of course, tool is just a tool, right? We will be the drivers to lead these tools to the best code quality. Because tool will not give you a code quality, but will give you a chance to code your application with a high quality. So again, please remember, try to, of course, choose the best tool which would work in your case, and of course, try to follow the good or the best coding practices to be able to utilize these tools in the best way, in the maximum efficiency. Next is shift left. I know this is a kind of buzzword nowadays, but I believe in practice it is really very difficult to achieve because do we really involve all the QA members in our meetings even when we start discussing about the requirements, the specifications? Are they involved even just after the development or even the planning stage starts? So this is being involved as early as possible, right? Because otherwise, if we think that okay, QA can sync with the development team at the very end and they can just execute a test case, believe me, we will fail. It won't work in that way. QA should be involved in the old processes as early as possible, and they can already find some issues or maybe usability, functionality, or some performance issues even during the requirement clarification stage. Because if we go to the QA at the very end of this development pipeline, of course, it might be too late because the development is already done. We put all the effort and the working code is already there, and we just got a feedback from the QA that something should or should have been done in a different way. So it would be too late. And similarly, shifting right as well. Shifting left is being involved as early as possible, and shifting right is doing testing in production as well. Not only in the testing stage before going production, but also afterwards. Even in the production environment, doing some verification activities to be able to see how the users are having an experience. Like this, some different activities might be involved in this process, like continuous monitoring, observability, and collecting all the evidences for the health of our application. So please remember to do verification in all stages. We remember the famous DevOps pipeline, right? The testing is involved everywhere, in the start, at the end. So shift right, shift left, shift everywhere. So testing is a key, quality is a key for our achievement in terms of the user satisfaction. One more hint, again, very simple, but again, in practice, which is not easy to follow and not easy to achieve. The pyramid, right? This is also a pyramid or the ice cream cone, but of course, it is not in the correct direction. But sometimes it happens in practice. Like we ask why QA did not find the issues, right? And we can similarly ask why it was not caught in the unit tests because we didn't have any unit tests. So it could already be found if we had some unit tests, but since we did not, then we try to verify everything in the system level. So which would be a very high load and which would be too much to verify in that level because if we try to execute our test cases in the system level, it would be too expensive. Unit tests are simple, right? We mock all the dependencies and we can run the tests for a very small piece of code. But end-to-end tests are mostly initiating the whole system and then doing some interactions on different interfaces. So it will be on the real running system and it will be, of course, slower than unit tests and, of course, difficult to maintain. If there is a problem or if there's a failure, we have to understand the root cause and it will take some time. But if we are talking about unit tests, we already know on which module or system or component we are working with. So it will be much more easier to understand the root cause. So please try to cover most of the scope in the lower levels, like the unit level, or even it might be integration level. But if we try to push all the verification activities to the system level or the acceptance level, it would be too much and it would be too difficult to maintain. It would be too expensive. So we are already discussing about the importance of the verification and the testing activities, and similarly, it applies to the test code as well. Whenever we implement some test code, whenever we automate some test cases, of course, we do some peer review activities, right? We should review the code. Similarly, as we do for the product code as well. Because sometimes I observed some discussions around code review to the test code. Saw some comments like, this is a test, okay, this is not as important as product code. So we don't have to review as strict as we do for the product code. But the test code is also going to the same repository, right? So if we have an issue, if we have a code quality issue, it will affect the same repository. For example, there might be some security issues, there might be some vulnerabilities, or there might be some issues which will slow down the pipeline. So if we don't have some strong quality gates, we will be letting those quality issues to go into production environment. And of course, just like a part of the application, the test code might also have a negative impact on the performance or the health of our application in the production. So we should review our code very carefully, and we should have strong quality gates. But what is the meaning of the health, or how we can ensure that we have a good test coverage, right, or a good test scope? Because it is not only the quantity. Like I can say, okay, I have 95% code coverage, which means I added a test for most of the functionalities, for most of the methods, most of the classes I have. My line coverage is very high. Okay, very good. But how about the capability of our tests? The strength of our tests? So I added test for all the lines, but my test doesn't do any assertion. It doesn't try to verify anything. So we should, of course, talk about the quality of the tests on top of the quantity. This is, again, another initiative that we can do in our projects. So please try to check the quality of your test case as well. How we can do is, there are lots of different ways to do that. Mutation testing is one way. You can just deliberately, intentionally insert some failures into your algorithms and try to see if your test is capable of finding these bugs or not. This means adding some mutants, like you intentionally change an operator and see if the test still, if it doesn't make any change on the test, if it is still passing or still failing, or after doing this change on the operator, the test is also impacted, which means it is capable of finding this issue. This is just an example, but of course you can follow lots of different approaches to have an insight about the health or the capability of your test cases. So again, it is not only the numbers, it is not only the quantity, but also the health, the quality and the health of the test cases that we are writing. So as we can have code smells in the application that we are developing, of course we can have test smells in the code that we are writing to automate our scenarios or the cases. What kind of test smells we can have? There are hundreds and dozens of types of test smells. As most of we are already aware of it, the one of the very popular ones is the flaky test, the test flakiness. But again, there are lots of different types: the fragile tests, or scope creep, or there is the understandability issues, readability issues, maintainability issues on the test code. There are lots of different types of test smells. But again, as we previously discussed, what this test smells will result in is reliability issues in two major categories. One is the false alarms, where the test fails, where it was not supposed to be, because the feature is working as expected. It is working properly. but my test case is failing. So it's not a real bug, right? It's a false alarm. On the other hand, test is not failing, it is passing. So I'm not aware of any issue, but there was a bug in the feature. So this is where we can talk about the coverage or the quality of the test cases. This is a silent horror case. One more aspect of the quality for the reliability of our pipelines is the quality dimensions, not only the functional but also the non-functional aspects of the quality. We can talk about the accessibility, maintainability, recoverability, portability, scalability. There are lots of different abilities. These are mostly the non-functional aspects. And one of the most important ones is, of course, the performance, because it will directly affect the speed and the completion duration of our pipelines. Think about, we can again have a very dense development activities. Everyone is pushing a new code almost every second, and think about all the pipeline is taking more than 1 hour. It's not acceptable, right? Everyone will start complaining about it. And of course, if we are talking about hot fixes, we should immediately fix the issues in production environment. So the pipeline should not take too much time. But if the test cases are running very slowly, then of course it means we have some performance issues, and it is just one aspect of the quality, but also there are lots of different non-functional aspects of the quality as well. So we should keep all these dimensions in mind, and not only the functionality, but also all these aspects will help us to improve our reliability and robustness of our pipelines. Because again, we already discussed about the time, but if it is too slow, then not only the blockage for going into production, but also blocking some other implementation tasks and doing some maintenance issues will be affected from this performance issue. So what we can do to get an idea, to collect some insights about the health of our product and even the pipeline itself, is we can collect lots of different metrics and we can do a continuous monitoring activity. Like for example, since we are already talking about the speed or the performance of our test cases, what we can do is we can observe our pipeline and try to collect all the metrics from different runs. In this run, for example, all individual test cases, test duration, I can check, right? This test case number 1 took 10 seconds. Test case number 2 took 25 seconds. So we can collect all these metrics and try to do a time analysis. Like we can have even understand which test case is the bottleneck. Like for example, in average, all the test cases taking, let's say 20 seconds, and one of the test cases taking 3 minutes, let's say. So this is the bottleneck, right? So what I can do, maybe try to parallelize all the suites, including all the test cases, and separate only this individual test case into another pipeline or a stage, probably. Because this is the bottleneck which is slowing down all the other test cases, right? Whenever everything else finish, we might be still waiting for this only one single test case. This is just an example, but again, we can collect lots of several metrics depending on our quality goals and targets, and then we can have an analysis on this continuous monitoring activities. So I know it is too much. Sometimes there are lots of different quality initiatives that we can do, but most of the time we are too busy, right? Okay, we don't have time to do this analysis because we already have lots of different implementation tasks waiting to be done. If I open my sprint board, I will see lots of tasks which are waiting for completion. So should I do this analysis right now? Actually, yes, I should. Because believe me, if I do this, maybe I will complete all the waiting tasks even in a faster way. Maybe this task or this initiative that I will do, it might be just a continuous monitoring, or it might be just a benchmarking of the tools that we are using, because maybe I will find a better way, right? So everything will be much more faster. But if I think that I don't have time to do that because I will do lots of different implementation tasks, maybe I will complete all these tasks in a way longer time. So these initiatives might help me to improve my performance and even the reliability and the robustness of our pipelines. Because sometimes we think that, okay, this is just one test case I can fix and continue because it doesn't take too much time. But if it is happening continuously, like some different tests are failing from time to time in different runs, then maybe it is time to stop for a moment. I know we are too busy, we have lots of things to do, but wait for a minute, stop everything what you are doing, and think about the root causes of our reliability issues or the robustness issues. This will help us a lot in the long term. Even though we spend some time on this analysis or the improvement initiatives, in the long term, it will help me a lot and it will fasten all the processes that I follow to complete my implementation tasks. So we discussed a lot of different dimensions and aspects in terms of the reliability and the robustness of our development pipelines, the delivery pipelines, because what we try to do is again delivering a high quality product and the application to our customers and do this as fast as possible. Quality and time are the two important aspects of our delivery pipelines, and this will be achieved by the help of a reliable and robust delivery pipeline. So thanks a lot for listening, and if you have any questions, please do not hesitate to reach out to me.